All right, question 10. They want us to actually do a good job of sketching this polynomial. So we're going to start off. Have a look at the final thing. So we're going to look at the factors of this, and this is what we're going to sub in to try and find our zeros. Factors of 20, positive 20. Well, we've got 1 plus net minus 1 plus minus 2 plus minus 4 plus minus 5 plus minus 10 and plus minus 20. So what I mean by plus minus is I could have had positive 1 times positive 20, negative 1 times negative 20. This is just a quicker way to write it. I'm going to start putting these in. So if I have p of x equals x to the 4, take 4x cubed, take 9x squared plus 16x plus 20. I'm going to start smashing all of these in. So let's start off with negative 1. So I've got negative 1 cubed, take 4 times negative 1, negative 1 to the 4, take 4 times negative 1 cubed, take 9 times negative 1 squared, plus 16 times negative 1 plus 20. All right, smashing it out on the calculator. Negative 1 to the 4, take 4 times negative 1 cubed. Something's gone wrong. I'm going to have to start again. Negative 1 to the 4. Take 4 times negative 1 cubed. Take 9 times negative 1 squared. Plus 16 times negative 1 plus 20. So I'm putting this in the calculator exactly as I did. So 0, therefore x plus 1 is a factor. Okay. Now let's try positive 1. So I'm going to go back through and delete all the negatives in front of my negative 1s. It's 24, so not a factor. All right, next one I'm going to try 2. So now I'm going to go through and replace all the ones with 2s. Sorry, this does take a while. Teaches you to be quite quick on your calculator though. 0, therefore x take 2 is a factor. Okay, I've found 2. Let's find some more. Ooh, p of negative 2 equals 0, so therefore x plus 2 is a factor. Now, technically I could start properly dividing at this point, but I'm going to keep subbing these in because it's so much easier than actually doing the long division. Okay, I'm going to try negative 4 now. $324. Okay, now let's try positive 4. I'm so over this already. I hope this is the last factor. Nope. Next one, we're going to try 5. Okay. It equals 0, therefore x take 5 is a factor. So glad we didn't have to then go through and divide that. I'm so glad we got 4 distinct factors. Sometimes life works out. Then sketch the curve. So if those are our factors, we're not going to do a good job of this, by the way. Oh yeah, well we kind of are. If those are our factors, we know it goes through positive 5. 1, 2, 3, 4, 5. It goes through negative 2. It goes through positive 2. And it goes through negative 1. The y-intercept. Let x equals 0, y equals positive 20. 1, 2, 3, 4. I'm going to make this 20. 6 was minus 2, minus 1, 2, and 5. Goes through positive 20, and behaviour as x tends to negative infinity. So what I'm doing is I'm finding out whether it starts down here, whether it starts up here. So I'm going to chuck in any number then less than that. So let x equal, let's just chuck in, well, I've already chucked in minus 4. Y equals positive 324, which means we're starting up here. We're going through, cutting back, going up here, and 24. Okay, I'm going to do this in a different color. So you get some weird looking ones of these, and no, I don't know if that's, yeah, that's essentially what we can do. So we know that, so this was our y equals x to the 4, take 4x cubed, take 9x squared plus 16x plus 20. And sketch this curve. We've finally done it. All right. Now let's have a look at this question, B. So this line touches it at 2 distinct points. So if I put a line through, it's a straight line. If it just was normal ones cutting there, it's going to cut it at 4 spots. 1, 2, 3, 4. But they're saying it only cuts at 2 distinct points. So I've got the feeling that means we're going to well, either it could cut there, look, implying they're saying double roots means I think they're going to talk about having it cut through. If we'd drawn this better, this could have gone like down here. Like it's going to cut through at those two. Because it's saying 2 distinct points. So let's say it cuts through at the points, at 2 distinct points. That means we've got y equals mx plus b equals, and we're calling these points point A, which is alpha comma something, and point B, which is beta comma something. So we have repeated roots at alpha and beta. So it's a quartic with roots alpha, alpha, beta, beta. We know it's repeated roots if it only touches twice. Explain why that's double roots of the equation. Okay, well let's just make the equation. So we have y equals mx plus b, and y equals x to the 4, take 4x cubed, take 9x squared plus 16x plus 20. Okay. So we know 0 equals x to the 4, take 4x cubed, take 9x squared, plus 16 take mx, because I've taken this m over to the other side, mx over to the other side, plus, and then now I'm taking that b over to the other side. So I've got 20 take b, and I'm going to put that in brackets as well. Okay, that's literally how they got that.